in this experiment, we're looking at how changing the concentration of a reactant affects the rate of reaction. And we're doing it by collecting the gas produced during the reaction. So this is a reaction of calcium carbonate, also known as marble, or marble chips in this case, and we're going to add it to some hydrochloric acid that I've already put in my conical flask there. Now the conical flask has got a bung on it and a side arm that leads to a gas syringe. A gas syringe is one of two possible methods to measure the volume of a gas, and I'll show you the method in a minute. But let's just carry out a simple experiment. I've used 2 moles per decimeter cubed hydrochloric acid. I've weighed out a precise amount of marble chips. I've got an exact volume of hydrochloric acid in there, 50 centimeters cubed. I've got to do 3 things at once. I've got to add the solid, put the bung on the reaction mixture, and start the stopwatch. Obviously you can't do all 3 at once, but here goes. And very rapidly you can see the gas syringe is filling up with gas, and that is pushing the plunger out of the syringe. And we can time how much gas is produced in 10 seconds. Hopefully you can see quite a bit of fizzing going on there, because when calcium carbonate reacts with hydrochloric acid, you get carbon dioxide gas being produced. And that's going up the flask, down the tube, and is being collected in the gas syringe there. It is quite a common exam question to ask you to draw or complete a diagram to show how the gas produced could be collected and measured. And it's important to note it wants you to measure the gas, not just collect it. So to draw a picture of the gas syringe, as we've shown here, you don't need to produce a work of art. You simply need to show some rubber tubing and a picture of a gas syringe. Again, I'm drawing this freehand, it doesn't have to be perfect. Maybe draw it with the plunger half out. And label it gas syringe. It's not a gas cylinder or a measuring tube or anything like that. You could also label the rubber tubing. And that is one way to collect the gas. Another way to collect and measure the volume of gas produced is to use a rubber delivery tube from a flask or a boiling tube here and run it into an inverted measuring cylinder, an upside down measuring cylinder inside a beaker of water, or a bowl of water, and the measuring cylinder is full of water itself. So when gas is produced, it will displace some of the water and we'll be able to measure the volume of water produced, say, each 10 seconds. So I'm going to do exactly the same as before. I've got my marble chips, I've got my acid already in my boiling tube, tip in the marble chips, put the bung on, start the stopwatch, and straight away you can see gas bubbling up into the measuring cylinder, and you can see the level of water falling as the gas displaces it, and you could be timing every 10 or 20 seconds the volume of gas produced. And one of the important things about this experiment is, because the measuring cylinder is upside down, the scale is upside down, and it can make it quite tricky to actually measure the volume of gas produced. So I'm just going to stop the reaction, or at least stop the gas being produced, and we'll zoom in and let's just see how much gas has actually been produced. So here is the line of the water, and that line there, where my fingernail is the 40 centimeter cube mark. Now, a lot of people, without thinking, will say, oh, it's under 40, count the number of divisions, it's 35. And this is quite a common exam question. They show you an inverted instrument of some form, like a measuring cylinder, and people don't always notice the scale is running downwards from smallest to largest. So this is not 35, of course, because the result is actually between 40 and 50. It's more like 45. Incidentally, when we're measuring the volume of a liquid, we should measure to the bottom of what we call the meniscus, the dip, although that's quite difficult to see in this example, and it's always much clearer in an exam question. So to draw a diagram of this method of collecting a gas, again, connect rubber tubing in the picture, have it curling like that, put it in some sort of bowl or basin, and upside down, and we're going to have to measure this, label this rather, we have a measuring cylinder. Now, the bowl of water and the measuring cylinder have to be full of water at the start, and to show that it's full of water while the reaction's taking place, do something like that, showing bubbles of water. I haven't spelled cylinder correctly. Okay, so that's how you would get the 2 marks for drawing a diagram of how to collect the gas produced using a measuring cylinder. And both methods, using a gas syringe or a measuring cylinder upside down in water, are equally valid. Some have advantages over others. For example, you can get a cheap measuring cylinder that's much bigger than a gas syringe. The gas syringes some schools use only can measure 100 centimetres cubed in total, whereas most schools will have measuring cylinders going up to 250, 500 centimetres cubed, even 1 litre. One thing to avoid in your diagram, and it's a common mistake, is drawing your diagram too small. And I sometimes see pictures like this, where, because they think it's neater, a pupil will draw something like that. Instead of drawing a tube, they just draw what looks like a wire. And a wire isn't going to get you the mark. It's got to be a hollow tube. Also, a common mistake, people will say, write a test tube there. That will collect the gas, but it won't measure it. You've got to use a measuring cylinder in this particular example. So, that won't do. So, having done the experiment once, you now need to repeat it because you're varying the concentration of the reactant. In this case, that's the hydrochloric acid. And the most important thing about this then is the concentration of acid is the independent variable. The dependent variable is the volume of gas being produced and being collected over, let's say, 10 seconds or however long you time it for. And that will give you the rate of reaction. If you produced 40 centimetres cubed of gas in, say, 1 minute, then the rate is 40 centimetres cubed per minute. But there are lots of control variables you have to think about. We're changing the concentration of our acid, but we must keep the volume of acid the same. We must also keep the mass of our other reactant, the calcium carbonate, the same. And, just as importantly, the surface area. So you must make sure you use the same size pieces each time. Another reaction that they may ask you about in the exam uses magnesium ribbon instead of calcium carbonate. And magnesium ribbon comes in strips. So if you have the same mass, you probably will have the same surface area. But they could ask you about using magnesium powder instead, and what effect would the powder have? It has a larger surface area, so the rate of reaction will be quicker. But there's one other very important variable I haven't mentioned yet that we need to control, and that is temperature. We must have the same temperature of acid each time, because the hotter the acid, the faster the reaction.